Good morning, everybody. It is my great pleasure to introduce our plenary speakers from Cambridge University Press and Assessment, Dr. Karatay, Dr. Lee, and Dr. Xu. I'm proud to say that all three are graduates of the Applied Linguistics and Technology PhD program at Iowa State, and they truly represent some of the best our program has to offer. Dr. Karatay and Dr. Lee are senior research managers, and Dr. Xu is head of propositions research English at Cambridge. Together, their work is advancing the use of AI and technology in English language assessment, from conversational agents and automated scoring to next generation assessment design and validation. Please join me in welcoming Dr. Karatay, Dr. Lee, and Dr. Xu.
Yeah, thank you for your introduction, and many thanks to Carol and the TSL organizing committee for inviting us. Yeah, as you said, we are products of the ALT PhD program. So this is a virtual homecoming event for us. So a few years ago, we were student volunteers helping to organize this conference, and we wish we could be there in person. I'm not sure about 𝘕𝘕𝘠𝘯𝘨, but I feel a bit nervous speaking in front of our former professors, as if we were redoing our oral defense, or as if we were recalled by the manufacturer. 𝘕𝘕𝘠𝘯𝘨, would you like to say a few words to greet the audience?
Yeah, it's hi everyone. It's really an honor to be back in Rosol, even though it's virtually. Like Jing said, I always try to be kind of a part of TSLL. When I was in Iowa as a part of the organizing committee. One thing that was missing regarding my TSLL portfolio was to be a plenary speaker. So I'm completing that task today, hopefully. So it's really an honor. Evan, you want to say something?
Yeah, hi everyone. Good morning, good afternoon, or good evening where you're joining from this conference. And I like that analogy of being recalled by the manufacturer, James. But I hope we pass the quality check at the end of this talk. Yes, I also share the sense of homecoming because seeing a lot of familiar faces reminds me how much this community shaped our thinking and research journeys. So today, I hope we can give back by sharing ideas that have grown from those foundations back in those days.
Yeah, thank you, 𝘕𝘕𝘠𝘯𝘨. So the topic of our presentation today is about the promises and the challenges of using generative AI in language education. This is a fairly broad topic, and generative AI technology has been evolving surprisingly fast. We try not to cover everything. So in this talk, we will focus on three applied areas, which are closely relevant to our current works in an assessment and a publishing organization. And we confess that we are still exploring the affordances and limitations of the technology, and there might be a research that we are not aware of. So the main goal of this talk is to review the current research trends on GenAI in an applied setting and identify research gaps that may inform interesting PhD projects. Okay, here's the structure of our talk. So we'll begin by setting the scene, talking about the great impact of the technology on the society as a whole. And then we'll zoom into three specific areas: automated scoring, spoken dialogue systems, and integrated learning assessment. And each of us will cover an area. And then we will identify some research priorities from each area. We are aware of other use cases of generative AI, such as automated content generation or data annotation for corpus linguistic research, which were discussed yesterday, but these are beyond the scope of this talk. And a few talks yesterday suggest that AI, generated language, and content do not have personal views or personal voices. So to distinguish us from AI, I'm happy to say that we will conclude our presentation by providing personal reflections. All right, so here's the scene about the big picture of the scale of the impact of GenAI on the society. This is a paper written by two PhD students in Harvard University in economics major, and they used the data from resume and employment across 285,000 firms between 2015 and 2025. So the chart on the left is about junior level openings, and the chart on the right is about senior level positions. And the y-axis in both charts represent an average employment metric. And you can see there's a solid line, a dashed line in each chart. The solid line represents the AI adopters or any job openings which include information relevant to AI use. And the dashed line is non-adopters. And you can see there's a vertical line in both charts. And the vertical line is the timeline about the time when ChatGPT was introduced on November the 30th, 2022. And you can see there's a tipping point for the junior level jobs on the left. There's a downward trend after introduction of the ChatGPT. And you can see the average employment for junior level position decrease overall, regardless of the AI adoption or non-adoption. And then there is a further decrease in AI adopters. On the right chart, you can see that the senior level positions remain consistent. There's a steady growth, and there's a less impact of ChatGPT use on senior level openings, senior level positions. So the authors conclude that generative AI has a bigger impact on junior level positions. Just to keep a note on that. And from the same study, the authors investigate the trend of generative AI adoption, and you can see two charts again. In the two charts, the y-axis stands for the number of firms posting their very first generative AI integrator vacancy or adoption of generative AI. And on the left side, the chart represents monthly figures. So you can see as the time moves on, there's a big increase of number of firms that are posting jobs relevant to use of generative AI. And on the right side, it's the cumulative function of the same information. So overall, you can see there's more and more openings which are relevant to the use of AI. So the impact is huge, especially on the job market in the United States. Now we're gonna zoom on to apply linguistics views on generative AI, and we can see that there's a very strong words being used to indicate the impact of AI use on the field, giving a sense of uncertainty, surprise, or even possibly anxiety, and giving an overall sentiment that the field is generally not fully prepared for the change. Now, here are some quotes. So Carol actually, in a recent paper, mentioned generative AI is a game changer for the field of applied linguistics. I'm not sure whether changing a good way or bad way. And there are recent breakthroughs in generative AI have shaken the field of language assessment in unprecedented ways. So these are very strong words given by Xinyuan and his student who is working at Duolingo right now. And also Nahal Kapazabashi, working from University of Bedfordshire, Quella, she mentioned that generative AI has emerged as a disruptive force in society. And this is quite a negative word, disruptive. So it's breaking the current practices of language education and bringing substantial changes to language education. So these are applied linguist views on generative AI. And at the same time, many authorities like UNESCO, ITC, stand for International Testing Commission, and Association of Test Publishers, ATP, they all publish authoritative documents regarding the guidelines or principles of good practice for using generative AI in either education, in high-stakes assessment, in qualifications, in learning, etc. I want to point out that Ofqual is a test regulation body in the United Kingdom. So all the Cambridge exams are regulated by Ofqual. And Ofqual mandates that the sole use of autoscorer as the primary marker in qualifications or assessment is not permitted. But there's no specific acceptance criteria being mentioned regarding automated scoring. So it's very general overall guidance on the use of AI technology. So our question is whether these authoritative documents are sufficiently helpful for practices in language education. Let's hold on this thought. At the same time, there's a big sort of desire about promoting generative AI literacy from language teachers, learners, and also assessment practitioners. And 𝘕𝘦𝘠𝘰, now previously working at ETS, now working on Hong Kong Examination Board, mentioned that the meteoric rise of ChatGPT and its sweeping application in almost every sector have left us in awe, scrambling to catch up by developing theories and best practices. Basically, we are not ready. The theories and best practices are still lagging behind. And also, Kerr mentioned that our profession is truly at an inflection point. So there are three ideas in his or her quote. One is that we need to investigate the affordances of technology, so identify what technology can offer. And we need to reconceptualize how practices should adapt to the new groundbreaking technologies, to rethink how we can adjust, make changes of our current practices, utilizing the technology, and also to investigate and understand the limitations of the technology, basically be clear about what technology cannot do, so we can design the best practices, good practice of using them. Okay, so I know Carol always mentioned we need to have research questions. This is our state of problem here for this talk. So the GenAI use guideline, the principles provided by the authorities, seem to mainly address high-level theoretical notions like security, safety, fairness, and justice, but they do not have clear practical utility. So they are saying we need to be cautious, we need to prevent doing this and that, but there's no specific guidelines. And so we argue that the affordances and limitations of GenAI in specific applied areas need to be still underexplored, need to be looked into carefully by professionals like us working in the field. Okay, now we are moving on to the first part, which is about using GenAI in automated scoring of L2 speech and writing, which is an area I focus on. So first, to lay the ground, how we define automated scoring for language assessment. So automated scores are trained to score complex constructed responses like speaking and writing. So they are used to predict scores that human examiners would give. And some auto scores may indicate confidence in score prediction, and they may also flag unusual aberrant responses, mainly to assess, sort of capture malpractice, cheating behavior, gamification behaviors, etc. And there are lots of benefits about automated scoring, like efficiency, cost reduction in large-scale assessment, and to mitigate examiner shortages, and to support on-demand testing. So traditionally, automated scoring is developed through a machine learning-based approach. I can tell that the mainstream auto scores are still machine learning-based. So these are bespoke models trained using expert label data from the live test. So basically, the text, the audio will go through the automated scoring system and produce a score, indicate confidence, and also produce flags, whether there's any possibility of cheating, different types of cheating, aberrant behaviors, etc. And this system must be trained by labeled data. The problem is that these models are usually proprietary technology owned by large testing organizations like Cambridge ETS. And model training requires a high level of machine learning expertise, and the training is usually data hungry. So there are several blockers. First, we don't necessarily have ML expertise in smaller testing programs. And also there's data scarcity, there's no high-level data. And so these are all the blockers for using an automated scoring system in a local testing program. So they are not quite accessible. Okay, so there are two ways to leverage GenAI for training an auto scorer. One approach has been investigated by 𝘕𝘬𝘯𝘨 and Alistair Van Moore. They previously worked at Mathematics. It's an auto scorer they developed for a EFL Young Learner test for British Council. Unfortunately, this talk was given at a local conference called Language Testing Forum in the UK back in 2023. But this is a very interesting study that hasn't been widely disseminated. So the procedure is that they generate synthetic data to train an automated scorer, and then they compare a model trained on synthetic data versus the model trained on real data, and then they compare the performances of the two models on the same evaluation set. The idea is to solve the data scarcity problem by replacing real data high-quality label data with synthetic data. Okay, what they do is they randomly pick a score and then they generate a learner response. So this is the prompt. You're an English language learner taking English writing assessment, and here's a prompt from an essay, and putting prompt here. There's a placeholder, and then construct response that it would give a score out of a score range, and then the rubric states that the score of this particular number indicates what, based on what criteria, the assessment criteria, and I write the essay here. The problem with large language model is that it produces native-like speech, and it cannot produce learner speech at this point. So they add additional layer, which is to prompt the large language model to contaminate or corrupt the response. And the prompt is like this: could you please introduce some spelling and grammatical errors that might be commonly made by English language learner into the following essay. And essay response is this, and update the essay with errors. It's a very innovative way to generally learn a language using large language models. And here are the results. So they generated 1,000 synthetic writings or responses, and also they have a comparable set of real data. Flat distribution across all the score points. So the same number of responses from each score category. And the evaluation set was 307 real student responses. So here is the evaluation result. So in the first column is the correlation. First row is the correlation. The second row is mean absolute error. Correlation, the higher the better. Mean absolute error, so basically is the margin of error. The smaller the better. Mean error is also another measure of margin of error. Also, the smaller the better. And you can tell, generally speaking, the model trained using real responses outperform the model trained using synthetic responses, especially in the mean absolute error and the mean error. The error almost doubled in the model trained on synthetic responses. And the authors actually look into the reasons why the model didn't perform well. What's the problem with the synthetic data generated by large language models? So the first reason they give is that synthetic data do not look like real data. So actually, this is an example. So you can see there's no way this response looks like a learner language. 𝘕𝘠𝘰𝘮 countryside, basically adding spelling error, synthetic error, grammatical error into that. But it's nonsense language. It doesn't look like learner language at all. Okay, the second reason is that with GPT, there's no way to measure confidence or model error. So GPT will give us a response anyway, but it does not really give you an idea of how confident the response looks like learner data. This applies to scoring as well. It gives a score anyway, unlike some deep learning model, which does not give you a score prediction, but also give you a confidence level. How confident am I in score prediction? So this is one of the major limitations of large language models, no confidence indication. And the third reason they gave is that they may be bias inherent in GPT, and the bias is too deep to detect. As you can see that we have no knowledge about training data of the large language model. They can be from anywhere. We don't know the quality of the data, and they are likely from native speakers production, but rather than learner language. So in a sense, large language models lack the knowledge of learner language characteristics, and correcting them using prompts is not really helpful. Okay, so we talk about generating synthetic data to train a traditional machine learning model. Now, there's another approach that some researchers in Cambridge have been exploring, which is to develop a large language model-based end-to-end automated scoring system. Basically, you are prompting the large language model to predict the score by ditching the traditional machine learning based approach. The idea is quite similar. So you have essay, a transcript going through a large language model, but you give them some prompts, like you tell them describing the descriptors for each score category, some rating criteria, some can-do statements, basically teaching the large language models to understand the typical characteristics of the language that are representative from each score category, and the model will predict the score. And again, there's no confidence indicator. Okay, so this is a general approach, and then we're looking into a particular study, which is from Stefano Bano and his colleagues from the Department of Engineering in the University of Cambridge. And they use a large language model, GPT-4, to score writing responses from Writing Improve, which is a Cambridge writing practice product. So the idea is that they write the prompt to let the large language model understand what are the dimensions of scoring. So the dimension fall into linguistic competence, pragmatic competence, and then the sub-criteria for each high-level categories. The purpose is to train the large language model not only to produce a holistic score, but to produce analytical scores as well. Because the traditional machine learning-based approach usually produce a holistic score. To produce analytical scoring, you need to train different models. So each model is separate to produce a particular analytical score. But this is a single approach to produce analytical scores at the same time. And descriptors and assessment criteria are being fed into the prompts. So here's the basically a flow chart of the training process. So given this assay and which received this holistic score, so they actually did a few shot prompting. So basically not telling large number anything, but just the score criteria to produce a holistic score. And then the second layer of the project is to tell the large language model the holistic score given by the human and give some few shots sort of prompting and let the large language models get feedback and then to produce analytical scores based on human holistic scores. There's a two-stage study research, and there are analytical descriptors. Basically, it will be asking large language models to place each response into a category based on each assessment criteria. So here are the results. They're about evaluation set of 7,912 essays from A1 to C2 on the CFR scale. And they're comparing the model with a baseline model, which is a traditional machine learning-based model. And you can see in holistic score prediction, zero-shot GPT-4 model reached a correlation about 0.797, which is lower than the traditional machine learning-based model. And also they used the GPT analytical scores to compare with some linguistic features, traditional computational linguistic features, which are relevant to the analytical category, like grammatical accuracy, vocabulary control, coherence and cohesion, thematic development. But there are some limitations of the study. One is that correlation is not the best measure of human-machine agreement. So we published a paper on that, arguing against using correlation. The other drawback is there were no ground truth human analytical scores in the study. So they had to evaluate the large language model prediction on analytical scores based on some computational features, which are conceptually relevant to these assessment criteria. So these are the drawbacks of the study. But we are working on creating analytical scores for the second stage of the study. Okay, so the second study was from Ma, and she was trying to build a end-to-end automated scoring system for L2 speaking. They use a large language model called Qwen to audio, and the same process, basically prompting a large language model to understand the types of assessment criteria, the characteristics of each score category, and send audio through the large language model and produce a score. So difference is that there's no cascaded components. So there's no ASR, there's no feature extraction, there's no grader or scoring model, just the one single model to be prompted to do the score prediction. And you can tell that compared to the baseline model, which is a holistic model, and also they compared the large language model with a Whisper ASR plus a BERT grader model. The zero-shot large language model didn't perform really well. The correlation was much lower at 0.64 as compared to the two baseline models, and RMSE with a margin error is very large. But by giving the large language model some example, like only 60 for human marking skill test, the end-to-end model, the pre-trained model, actually performed quite well. It's actually better than the foundation model or the baseline model. So showing some potential promises of using large language model for automated scoring. Okay, to conclude, we saw some benefits. So the large language model based on automated scoring is highly accessible to non-experts, and it reduces the demand for high quality training data. And it's a single model for predicting analytical score. You don't have to generate separate models for each analytical score. And there's some sort of score explainability because you're sort of training the large language models in the same way that you train an examiner, because you're telling the model about some assessment criteria, right? But there are some challenges as well, because large language models cannot indicate confidence or model error to give a score anyway. So it's very difficult to tell when score is accurate. So there's no room for hybrid marking. So the hybrid marking is in a way that when auto scorer is not confident, indicate sort of low level of confidence, the human examiner will kick in to replace the auto scorer. And also, large language models lack knowledge of L2 characteristics, and also there's some unknown bias in large language models that we are not sure about. And there's a chance of large language models which are susceptible to adversarial attacks or malpractice. GPT is constantly evolving, so we don't know how model perform from one version to another version. And finally, there's an accountability issue. We don't know who is accountable, whether it's a testing organization who are doing the prompting, or whether it's the builder of the large language model who is accountable for inaccurate score prediction. Okay, I'm going to move on to the next part, to Yasin to talk about spoken dialogue systems.
Thank you, Jing. So in this part of the talk today, I'm going to discuss one recent technology that has become kind of an interest to researchers, which is spoken dialogue systems. So researchers seem to explore this kind of technology as a possible alternative to face-to-face interviews to assess dialogic communication skills. So what are these systems? They are basically computer-based applications that can interact with humans using natural language. So they can ask questions, respond to what the speaker says, and maintain a flow of conversation, much like a human interlocutor, right? So what's really exciting here is the construct expansion that dialogue systems makes possible. So instead of limiting speaking assessments to monologic tasks, these systems allow for real-time interaction that kind of simulates real-world conversations. And these systems can also elicit a range of aspects of interactional competence. And another major advantage is practicality, which means because there is no human interlocutor involved in these systems, they can operate 24/7, they can test large numbers of candidates, they can ensure consistent conditions across administrations, which brings us to the issue of standardization. So this is another kind of advantage of dialogue systems, because we know that even highly trained examiners can struggle to deliver speaking tests consistently because of several reasons, right? So in many ways, dialogue systems offer an appealing kind of alternative to assessing dialogic speech. So after seeing all these kind of advancements in the GenAI world that Jing kind of introduced us in the introduction, the question then becomes, how could large language models impact or reshape this specific area? So I guess we can say that with the integration of large language models, we're kind of moving into a new generation of dialogue systems, systems that are kind of far more flexible, far more adaptive, and more kind of context aware. So these kind of LLM-powered dialogue systems can, for example, function as virtual interlocutors in task-based interactions. And instead of delivering, for example, fixed prompts or predetermined responses, they can engage test takers in dynamic kind of exchanges that kind of feel conversational and authentic. And they can also simulate rich and contextualized scenarios that mirror real-world language use, like term management or repairing or negotiation of meaning. And another powerful capability is the delivery of corrective feedback and adaptive support, which is very important, especially considering the considering dialogic kind of systems as a learning tool. So LLM-powered kind of systems can respond more intelligently to learner errors and can potentially adjust the level of scaffolding in real time. So we're kind of witnessing a transition from rule-based to large language model-driven models, which enables kind of conversations that are much more natural and coherent. So let's see how they work. Just briefly, I'm not going to go into too much detail. You might have seen kind of similar figures in different presentations if you're interested in this research area. But for those who are not, I'm just going to go through each step without being too technical. So just a typical spoken dialogue system follows this cycle. It starts when a test taker or learner speaks, and then that audio input is processed through speech recognition and understanding component, which converts the speech signal into text and then kind of interprets its meaning. And then that specific output goes to the dialogic management component, which is kind of the brain of the system, which decides what to say next based on the user's input and the system's algorithmic goals. And then the system moves the speech moves to the kind of speech generation module, where the response is formulated as text and then synthesized into this kind of speech output, and then completes the interaction pool. So what's really important here is the middle component, the dialogue management component. Traditionally, this part has been kind of rule-based. The system followed kind of pre-scripted decision trees and then keyword triggers. That works fine for very kind of constrained tasks, but it sometimes leads to rigid and then kind of unnatural kind of conversations again kind of depending on the task. So like I said, we are seeing a shift toward kind of LLM-driven dialogue management systems where LLMs are used specifically to understand user speech and generate responses kind of dynamically, which hopefully makes conversations much more fluid and kind of contextually appropriate. So what's the value of these systems in our context? I'm going to think about this in two kind of different contexts, for language learning purposes and for language assessment purposes. On the learning side, as you can see, the benefits are clear. So for learners and teachers, these systems provide kind of safe opportunities to practice and develop communication skills without the fear of embarrassment and anxiety. And they can offer a variety of feedback, and not just on correctness, but also on fluency and potentially on interaction and other sub-constructs, which in turn helps learners to kind of build confidence in speaking, because they can be adaptive and they can also make it possible to personalize their learning journey, which is very difficult to achieve in a traditional and crowded classrooms. So institutions also gain here, and they can design innovative new courses, and they can attract more learners, and then more importantly, they can demonstrate students' kind of readiness in a more tangible way. On the assessment side, dialogue systems kind of allow test providers to simulate authentic and real-life social interactions, like I presented in the previous slides. Something that has always been a challenge, especially in large-scale testing. They bring a higher degree of standardization, which eventually supports fairness, while still balancing the communicative richness we want with the operational practicality. For institutions, these systems are often less resource-heavy and less logistically complex than face-to-face exams. They're easier to scale up, which is a critical issue when you think about global demand for English and other languages. But there are some limitations as well. For example, current systems sometimes dominate the conversation instead of letting the learner lead, which is an issue, especially in high-stakes assessment context. So they may struggle to adapt to learners' level, and they may produce kind of inconsistent responses or sometimes misinterpret accents. So these are kind of active areas of research and development. But even with those challenges, the potential value, I believe, is substantial. So we are going to show you a demo of a speaking app that uses generative AI for learning purposes specifically. So in this tool, learners can pick a topic like the ones that you see on the left side, chat about a day, chat about a topic, and then they pick a subtopic from a variety of topics. So we're going to play an audio of myself interacting with the tool on the topic of cooking and making pasta, which I like to do very much. Let's listen.
Hi there. Let's talk about cooking. What's your favorite dish to cook?
I like cooking pasta.
That's great. Pasta is delicious. What type of pasta do you like to make?
I like pasta with pesto sauce.
Yum. Do you make your own pasta sauce or do you buy it?
Yeah, I make my own pasta sauce.
Nice. Making your own sauce is fun. What ingredients do you use for your pasta sauce?
I make pesto with basil, nuts, garlic, olive oil, and parmesan.
All right,
Hi
so
there. Let's talk about cooking.
you got the idea. So this conversation goes on like this for about 2 minutes, and then at the end, the users see this screen. They have two choices. Either they can go back to the previous discussion by clicking on continue conversation, and then they can just practice more, or they can just end the conversation here and then look at the feedback. So what you see here is a and what you heard is a very early prototype version of the tool that is going to be integrated into a learning product very soon in one of Cambridge materials. So we just provide very basic level of feedback on the screen on vocabulary and pronunciation specifically. And you can kind of imagine the same technology being used for assessment purposes as well. So in the next section, Ḥeybon is going to talk about how to integrate learning and assessment together using such technologies.
Thank you, Yasin. So the third area we'll focus on today is the use of GenAI in integrated learning and assessment, or ILA in short. This is where teaching, learning, and evaluation intersect. So rather than assessment as a separate event, ILA captures evidence of learning as it happens, and this is where GenAI can have transformative potential. So since ChatGPT's release in late 2022, we've seen an explosion of GenAI use across education. So it's no longer just a tool, and it's becoming a new literacy. So ministries and universities are already piloting AI-assisted pedagogy and evaluation in a strategic manner. So for example, the Perkins Group introduced the artificial intelligence assessment scale, and in their subsequent study showed that when GenAI is integrated ethically in educational assessment, it can reduce academic misconduct, improve engagement, and sustain integrity. And in the context of English language teaching, for instance, Han et al. 2023 demonstrate that in EFL writing, GenAI can work well, but only when teachers remain central. So teachers still guide students drafting and revising rather than being replaced by AI. And these studies mark a shift from reactive to strategic AI use. So in the next slide, in integrated learning and assessment brings, Jing, moving on to the next slide. Is there any technical issue? Oh, thank you. In ILA brings instruction, and evaluation together. So instead of teaching first and assessing later, students learn through assessment tasks. So assessment tasks become learning tasks. And Johnson et al. 2016 describe ILA as continuous, feedback-driven, and authentic, and aligning assessment closely with real-life communication in the learning context. And the figure you see at the bottom of this slide describes this integrative cycle well. So at the classroom, so the micro level, we start with a task that elicits real interaction, and the teacher observes what learners actually do and may jot quick notes, including mental notes, as the interaction unfolds. And learners then get feedback from the teacher and peers, and the task adjusts as needed, so repeated, extended, or add scaffolds. And alongside that, the teacher captures a simple structured record of each student's performance, and those records are then interpreted against a common frame, say the CFR, and rolled up into periodic summative checks on progress toward the bigger curriculum goals. So with GenAI, this integration can become even more dynamic. So tasks can adjust in real time more easily, and feedback can be given more frequently and systematically as students learn. So what does this all mean, look like in practice? GenAI can offer 4 key affordances. So first, personalization, adaptive feedback and prompts tailored to each learner's profile. And second, scaffolding, models and hints that support learners, for instance, in writing at the stage of planning, drafting, or revising. Strengths shown in the study that I introduced earlier in the previous slide. And third, engagement and autonomy. So take speaking as an example. Interactive dialogue, as demonstrated by Yashin earlier, keeps learners motivated and reflective. And fourth, inclusivity. So multilingual and culturally responsive interactions powered by GenAI may help lower barriers for diverse learners. And in practice, AI writing tutors, such as Write and Improve that Jing introduced earlier, can support revising strategies. Speaking bots can simulate real-time conversation, as we saw in Yashin's demo earlier, powered by real-time feedback. And reading tasks can adapt question difficulty automatically. So to illustrate how GenAI can enhance the cycle of integrated learning and assessment, I brought an example from 𝘕𝘴𝘪𝘀 et al. 2024. But the researchers did not explicitly state that the pedagogical design piloted in the study followed the ILA cycle, but each phase and step maps neatly onto it, so I'll use it for illustration. So the study was a 10-week experiment with adult learners in intermediate level Iranian EFL writing classes, and a structured GenAI-based writing instruction protocol, which consists of planning, instruction, and assessment, was trialed. So in the planning stage, phase 1, teachers utilized ChatGPT to generate lists of materials and samples to fit each session and to design a wide range of writing tasks aimed at different types of writing. And in the instruction phase, so phase 2, each session included student chatbot interaction. The teachers provided guidance on using ChatGPT beforehand, and students worked on their writing tasks in the classroom and at home with support from the chatbot. And ChatGPT broadened the range and quality of feedback. So students submitted their writing to the chatbot and requested detailed analysis and feedback. And afterwards, teachers discussed the strengths and weaknesses of the students' writing, drawing on ChatGPT's suggestions. And in the assessment phase, phase 3, the analysis and monitoring of student writing generated by ChatGPT provided an additional basis for teachers to design writing tasks for the next session. And this cycle then repeated. So the findings suggested that this GenAI-powered approach increased teachers' self-efficacy and improved learners' writing, with gains persisting on the delayed post-test. But these promises come with caution. So first, blurred boundaries between learning and assessment and pedagogical dependence on AI may raise concerns about fairness. So in AI-mediated tasks, formative help, such as AI reformulations or hints, can flow directly into graded work, making it unclear how much performance reflects the learner versus the tool. To keep decisions valid and comparable, we need clear models on permissive AI support, consistent conditions, and transparent disclosure of AI involvement. And second, there is a risk of construct drift. So if AI changes the task too freely, what are we actually measuring? And third, equity and access remain critical. So not all learners have equal technological literacy or access to AI tools. And at the same time, data ethics should also be a concern, as large volumes of data are collected while learners engage with AI tools. And finally, we must maintain theoretical rigor in pedagogy, grounded in strong theories of second language acquisition, pedagogy, and related fields. And this ensures that AI is used for valid, pedagogically sound reasons, not simply for the sake of applying it. So responsible integration means keeping people, not technology, at the center. And we can think of this as a partnership between educators, learners, and AI systems. So educators guide test design and interpret feedback, and learners engage critically using AI output as a scaffold, not a substitute. And AI systems provide data and support, but must be transparent, explainable, and accountable. So in short, human in command and AI in service.
Okay, I pick up from here to identify some research priorities for large language model-based automated scoring. So there are four major categories. The first is about reliability and accuracy. In the talks from yesterday, people were talking about the consistency of generative AI predictions and notation. The same issue applied to automated scoring or score prediction. So we need to see check the potential bias in automated scoring system that are trained based on generative AI, so AI performance across L1 groups and proficiency levels, and also AI prediction in analytical scores, especially on criteria beyond linguistic competence. And also drawback is about confidence indication in score prediction. So it's about AI not have the knowledge about they don't have the knowledge. So we need to train AI to identify cases that when it cannot make prediction or they learn about the errors or error prediction. The third area is about malpractice detection, prompting large language models gain knowledge about error responses or cheating behaviors. The final category is about explainability, or can large language models sensibly explain the rationales behind the scores they give? Guessing?
All right. Yeah, sorry. I was unmuted. So regarding the LLM-powered dialogue systems, we've seen some exciting possibilities, right? But there are also significant challenges. And as you know, as researchers, we love challenges because they lead us to research priorities, all of us who are interested in this area. So first, and there are questions around cognitive validity. We need to make sure that the task demands in AI-mediated interactions actually align well with the kinds of cognitive and interactional processes that kind of occur or might occur in real human-human communication. For example, are test takers engaging in similar planning, monitoring, or repair strategies when interacting with an AI as they would with a human interlocutor? So that's a question. Next, context validity, which raises concerns about the authenticity of the AI-mediated communication. So the dialogue may feel more constrained or artificial compared to human exchanges, which could affect both task performance and the construct being assessed. We have to consider how individual differences, such as first language background or familiarity with AI, influence interaction patterns. For example, learners who are more comfortable with AI might have an advantage over others that are unrelated to their actual speaking competence. And there are also research areas around scoring validity. For example, our existing human-based rating scales were developed for evaluating performance in human-human interactions, right? But when the interlocutor is an AI, some of those descriptors may not apply. So we may need new scales or descriptors to capture what effective communication means in AI-mediated dialogue. And then finally, for consequential validity, which concerns the broader impact of using these systems in assessment and learning. So we need to think critically about the fairness and 𝘍𝘠𝘨, specifically how learners perceive the use of AI interlocutors and how that might shape their language learning processes or their test preparation, right? So if the interaction feels inauthentic or too mechanical, it could undermine test taker engagement and learner engagement, and even with the kind of perceived validity of the assessment. So handing it over to Ḥivan.
Yep. And the following research priorities can guide us in the area of ILA. So 4 priorities stand out. So first, pedagogical design and SLA grounding. So how AI-mediated ILA tasks align with learning theories. And second, validity and construct evolution. So what are we measuring and how may AI alter constructs? And third, ethics, equity, access, and sustainability. So ensuring transparency and fairness. And lastly, learning impact and transfer. So tracking long-term gains and how learners transfer AI-supported skills into new contexts.
Thank you. And this is our one-sentence remarks, personal reflection for each area. So from me, I feel like generative AI may have made automated scoring more accessible to teachers and assessment practitioners, but there's still a long way to go to investigate, especially on investigating the limitations of large language models. So this is quite necessary before this technology can be responsibly used in high-stakes language tests.
And for me, the key question is not whether GenAI will transform speaking assessment or not, because it will, but how we can guide its development responsibly to enhance validity and fairness is the main question.
And for me, my final takeaway is GenAI is increasingly being implemented in integrated learning and assessment contexts. But we must not lose sight of the depth of our pedagogical understanding or of the theory-informed best practices established before the era of GenAI. So we should continue to implement it in a principled manner as we have to date.
All right, and I think it's a great homecoming event. We welcome people from Iowa State or from other institutions who come to Cambridge, the Triangle Building, which is the headquarters of Cambridge University Press and Assessment, and hope to see you there in the future. We're going to open the floor for questions. See you in the future has 2 meanings. You can visiting us or joining us. We hope that our ISU or ALT program can be a feeder program. We hope to see more students joining us after graduation.
Thank you. We have time for 6 minutes for questions. First, we'll see if there's questions in Ross. Yes, one question.
First of all, thank you so much. This was a fantastic presentation. I really enjoyed it. Thank you, Yasin, Jing, and everyone. My question is, the whole notion of, it has to do with the fact that ChatGPT 4 will be 5, will be 6, will be 7, will be 8, will be 9. How do you set this up so this can be something that can be addressed with each release of every single new ChatGPT version or whatever LLM you're using? And then sort of a question related to that is, how do you feel as Cambridge about losing some of the propriety that you had with systems that you create in terms of generating the resources that you need to keep going?
That's a good question. I think we are all struggling to catch up for sure, because the models are evolving rapidly. I don't have a definitive answer. I mean, we have to catch up. I mean, we have to keep sort of exploring the latest version to see what add-on value the latest version give us. They might be not for the applied linguistics field. It may have sort of add-on value for other disciplines. And I don't know, to be honest, to how to catch up with this ever evolving models, model development. As to the losing the advantages of a large testing organization, we used to have the data. We have a large amount of human label data, which is the advantage of the large testing organization. But I don't think we can be against the trend. I think auto scoring or spoken dialogue system will be more and more accessible to laypersons. There's no way we can stop this trend or to be against the tide. We have to follow this trend in some ways and be more open-minded to share the data with the end users. We're not really protecting data anymore, but try to collaborate with the field to make the assessment or learning products more accessible to the community. Yasin and Hui-Wen, do you want to add anything?
Just one thing, Volker, especially for your first question. I think in terms of the delivery of using GenAI to deliver assessment products like the one that I presented, I think a modular kind of approach makes more sense because you're kind of developing capability here and you're testing the idea. So I want to focus on the capability and the idea. And then when a new product comes in, and if we believe it's better, we can just switch it. So it's basically we had to do it in a couple of kind of research ideas that we had done. For example, we first started with GPT 3.5, and then 4 came in, and then 4.0 came in. So it just took a couple of hours to just switch to the new model. And then if we decide that in terms of the cost and other things, if we decide to go with a new model, you just a couple of lines and then you switch to that model. So I think it's about how you design the systems. So again, I'm speaking from the delivery perspective. So for automated scoring, it might be different. But again, the idea is to test the capability and the idea, basically.
Okay.
Anything to add, Hui-Wen, or one more question?
Yeah, just to add, I guess, referring to your second question, Volker, I guess it's our responsibility to maybe look for some specific areas where we can actually excel than just lay people or just practitioners in the classroom, so that we can provide the unique features that we can deliver at best, but that can be easily implemented in the classroom where this, different versions of generative AI technology is continuously being implemented in the classroom. But it's an area where we need to explore, I guess, continuously.
I think we are sort of setting the standards about responsible use of AI. This is something we can do because the technology can be more accessible, but can be used in an irresponsible way. I think a leading organization can set example about using technology responsibly, ethically.
Thank you. We do have a raised hand from Victoria Santos, if you can unmute.
Alrighty, well, first of all, thank you for the great presentation, and it's truly wonderful to see the three of you again. I have a quick question. So in the more traditional NLP-based models of automated scoring, both of written text and speech, it's a more explainable model. You understand the features that are being extracted, and it's easier to know what's going on under the hood, so to speak. But we know that deep learning models are more of a black box, and it's harder to explain what's going on, but we have seen over and over again that they are able to lead to better results, especially accuracy. So my question is mostly for Jing, but basically for all the presenters. Jing, you talked about the importance of explainability in large language models in terms of research. But I remember a presentation, Alistair von Moore was in the presentation as well, and you said that you don't need to understand how a dishwasher works. All you care about is that you have clean dishes at the end. So how important do you think it is that we understand what's happening over the hood? Or do you think that the proof is in the pudding? If the scores that it's giving out in the end are accurate, sometimes even more accurate than the humans are able to, Do you think that that's all that matters at the end?
I think it's a philosophical question regarding the process. I do feel like large language model give us a chance, opportunity to train a system in a traditional way of training human examiners because you're telling them the assessment criteria or some typical features in learner language that fit in each score category. So in this way, we're aligning the training of automated score system with training of examiners. So that's why I said it's more explainability. And when you're taking a step back, when you're thinking about those scoring feature-based model, do you think those features are explainable, like length of runs, the number of pauses in speech? It is explainable to some extent, but it's not really sort of interpretable from a construct perspective. It's sort of surface level features. I think I would see like if explainability can be achieved when large language model can explain the rationale of the score behind the score prediction, and also the rationale is sort of warranted by human examiners as well. So validating the rationale from the large language models is the ultimate goal of explainability for automated scoring. So giving a reason why. So this is what is missing in the traditional machine learning-based automated scoring system. If we can ask the large language model to give a score and give a reason, and the reason is valid, then I think that automated scoring is truly explainable on that day.
Great, thank you. We have one question in the Q&A. If one of the speakers can respond just briefly for time. In educational contexts with limited self-regulation, how can we prevent GenAI from deepening cognitive debt and eroding learners' active mental engagement?
Anyone would like to pick up? This is about learning.
Okay. Deepening cognitive debt. Oh, the question disappeared. Okay. Yeah, now I can find it again. Yes. I guess it really depends on how you really design the whole learning and assessment, I guess, practice. And I remember the assessment scale I introduced as part of my presentation, the AI assessment scale that actually has a range of involvement of AI depending on the goal of the outcome that you'd like to actually derive from the practices that you do in the classroom. So it can start from like no AI at all the way to AI exploration. So I guess it really depends on the outcome they want to actually drive from the practices that you actually try out in the educational context. So depending on that goal, I guess you can design whether you can actually provide more free, I guess, space for learners to actually engage with their own cognitive ability and also creativity at the same time, or if the goal is to actually help them to explore the use of AI in certain contexts, then you design the text in the way that they can actually use or get some support and help from that AI use, and then also implement it in this context. So it really depends on the goal of the practice that you design and also implement in the context.
Yeah, I agree. I think it's a shift of a focus, like in cognitive work. I think I confess that I use Copilot sometimes to fix some language, but at the sentence level, to make the language more native-like, because I'm not a native speaker. But I think I put more effort, energy on the discourse level, sort of coherence, idea flow, etc. I don't think it will cause a cognitive deficit. It's just a shift of energy from some surface level language correction to high level, metacognitive level, discourse level, sort of improvement of the writing or speaking. Just the different ways of working because of the introduction of the technology.
Great, thank you very much. That's the time we have for questions. Thank you to our presenters. If you can spend some time in the chat answering the many questions that you have, that would be great.